Welcome. In this last tutorial, I'm going to talk about setting up the game loop and the logic of making the two players target each other. So to remind you, in my implementation, um, I left with an incomplete implementation with the two players setting up their own boards, and then there's a game loop, and each player is aiming on the other one. So in my implementation, which is currently incomplete, each player is setting up the ship, and the ship is one cell. So just keep in mind that my implementation is not the full one. Each ship is one cell, uh, but that doesn't affect the logic of the game. That same structure for the logic of the game should work when the ship is not one cell. So let's keep this in mind as a limitation because I haven't completed the game setup logic that creates different ships of different shapes. Now remember that the human player will be setting up the pieces by entering coordinates, and the computer player will be setting up the ships by just selecting some random coordinates. So what I'm going to do now, I'm going to make a small change, which is basically to automate creating the two boards. So this change is only for the sake of testing and developing this game because I don't want to enter coordinate every time I'm playing the game. So I'm going to make this change and then take it out when I'm done. So notice that if the human attribute is true, we're calling the method think, which basically interacts with the user. Otherwise, we call the method compute, which selects random coordinates. So what I'm going to do now is to do compute in both, which will basically then randomize the ship's location for both players, the human and the machine players. And you can see now that it's now printing two random boards for each, which is handy because I don't want to enter coordinates for my every time I'm testing this game. So let me just leave a note for myself to remove after deep testing. So right now, the skeleton for the game loop is the following. Each player will call a method called shoot, which is basically the method responsible of selecting a certain coordinate to target. Now those two methods, the two players have to communicate somehow. Because once the player selects a certain coordinate to target, the player needs to know whether that shot was a hit or a miss. And right now, of course, there is nothing in this method. It's just like a stub to be completed. And we need to think about how to make these two methods communicate. Now, remember when you play this player using the physical board game, the other player usually gives the information of whether this certain coordinates were a hit or a miss. So we have the option of doing this the same logic here, that the first player will shoot and then the coordinates resulting from that method can be passed to the second player in order to know whether it's a hit or miss. So the way I'm going to set it up is the following. I'm going to assume that the method shoot results in two coordinates being selected. And these two coordinates will then need to be checked to see whether it's a hit or a miss. So I'm going to go to the method shoot here, and instead of this method being void, I'm going to assume that it returns two coordinates, x and y. Now, of course, a method in Java can't return two things. So you can't return int that doesn't exist in Java. It has to be a certain data type. Since I'm receiving two coordinates, I can return a collection of integers or simply an array of integers as a result. So basically here you can then create this array. So let's call it coordinate. And it has two elements because it's an integer. It's an integer array. Of course, this has to be an array. And then at the end of this method invocation, we can return that array here. So what am I trying to do? I'm trying to return the x and y resulting from calling this method. So of course, this is right now 0, 0 because there is nothing there. My goal is here is to try to finish up kind of the logic of connecting game and the two players and also game. So let's assume that when the first player calls that method, it's storing the results in coordinate 1. So those are the results of that player selecting a certain cell to target. And similarly, we can do that for player 2. If you stop at this point, coordinate 1 should be 0, 0. And I'm going to do that. So at this point, we can see that this coordinate is 0, 0, and if you step also over this one, coordinate 2 is 0, 0, 2. Now, of course, we don't want this to happen. We want each player to be able to select a certain coordinate. So it shouldn't be 0, 0 all the time. So what do we do? Well, of course, this depends on whether the player is a human player or a computer player, because the human player will need to select these coordinates, and the computer player can make a random choice. Of course, if you're programming a game, that choice shouldn't be random. It should be a bit more thoughtful than random. Let's say, for the sake of this example, that the choice is random. In the case of computer player. So what I'm going to do, I'm going to check whether this player is human or not. And depending on that, we either choose random coordinates in the case of computer player, or we choose we probe the user to enter these coordinates. Now, of course, when it comes to board, we represented the fact that there is a hit or miss, and it makes sense to take a look at these. It makes sense not to allow the player to target a certain cell which is already hit or miss. All right, so that's an extra step, but it's important because if you're making those selecting coordinates randomly, you don't want to select the same coordinate again and again. So let's take a look at each one of the cases. What I'm going to do here, I'm going to insist that the player keeps trying to enter coordinate. Again, my idea here is to limit the player of selecting a certain cell which has already been targeted. So what we're going to do here, we're going to probe the human player to enter coordinate with the same strategy, entering column and entering row. And then what we're going to do here is to read the column, which is the Y or C. And we can use scanner next int if we have access to a scanner as an attribute, which is scnr in my code here. So next int. and then I'm going to ask for the same one, X. Now what I want to do, I want to check the enemies board, because the enemies board is the representation of that board here. So I want to check the cell X and Y and see whether it's a hit or miss or something else. So here in enemies board, there is an array called cells here, which contains the representation of this board. What I'm going to do here, I'm going to create a method called checkCell, and this method should take X and Y, row and column, column and row, and tell us whether it's ship, C, ship, hit, miss, or something else. I'm going to do public char check cell, and this one will take take a row and column. And we can basically return cells row column here. I'm going to go one step further than that. I'm going to basically try to deal with incorrect input here. And the reason is, if those numbers are entered by the user, there is a chance they go out of bound. So the idea here is that I want to ensure that it's an OpenC. So I'm going to do the following. I'm going to check that the input is correct. So I'm going to try. So char result. Let's say in beginning it's unknown, and I'm going to return that result here at the end. So result will be trying to check the content of this array, and if you get an exception, and the only exception you can get here is array index out of bound, which is a type of runtime exception. I can basically print an error message like invalid cell, or just do nothing. Let's just print incorrect cell selection or incorrect selection at let me format it as kind of like a two coordinates r plus c plus the parentheses here. Okay, so when it comes back to player, what I'm going to do here, I'm going to try to see what's currently inside that cell in enemies board. So enemies board.check cell R and C. So it makes sense we call those R and C instead of X and Y, but basically it's the same idea, R and C. And only when this cell is an OpenC, we should make the player make that selection, right? The player shouldn't be allowed to target an already targeted cell, which is either hit or miss. Of course, it won't be a ship because initially the player doesn't know about the enemy's board here. So what I'm going to do here, I'm going to insist that if this cell is board C, then that's the correct selection. What we're going to do here, we're going to update coordinate 0 to be the x. Again, this is convention. I'm doing x and y, so coordinate 1 would be a row, coordinate, so the first one would be a row, the second one would be the column. And then I'm going to break the loop. And of course, the loop will not break if this is not, this condition is false. Now let's go back here to game. Now part of deliverable 1 was basically to print player 2's board. But of course, in the real game, you don't want this to happen because you want the player to see the other player's board. So what I'm going to do, I'm going to turn off this one. I can keep it, it's not a big deal here. And well, let me keep it here, just so that I know what's the other player's board here. What I want to do here, I want to print the player's one knowledge of enemy's board, which is initially all OpenC, and then it will change depending on the the user entries. And let's see if we have such a method here. We have a method called print enemy board, which will print that board. So here, before trying to make the selection, I'm going to make player 1 prints enemy's board here. And let's see, player's game.player1.print enemy's board. Okay, so now if we run, I'm just going to do system out print line coordinates 0 plus coordinate 1 here. Of course, it's coordinate 1. So let's run and see what we have here. So you can see that the two boards, the two selections, oops, we do here. Oh, something funny. So you can see that the two selections here, the two board selections are here, and then this is the game loop. And in the game loop, this is my enemy's board. I don't know anything about the enemy's ships, right? This has been printed out just for testing purposes. And then it's asking me to select column row. And what's nice in here, if the exception logic works fine, it shouldn't allow me to do some wacky things like this one. It will say like, it's an invalid selection, so why don't you select column row, so 3, 2, and then it's 3, 2, so on and so forth, right? So that's the human player targeting the enemy's board. Now what I want to do, I want to make the same thing happens for the computer player. Let's go basically reset that perspective. Reset perspective. Okay, so let's go finish the logic for the computer player here. When it comes to the method shoot, it's very similar to how we differentiated between think and compute. What we can do here, we can have a loop. And same thing, we need to enter rows coordinate, but of course we're not entering them. We have to randomly generate them using random. So that's the same logic here. So I'm going to int c random, and of course we have to do the same logic we've done here. It's random cap to the columns from 0 to column -1, and same thing for rows from 0 to row -1. So that's that, and this one should be the same. So check enemies board at RC. If it's .c, check that and break this loop. Now if you're thinking like what I'm thinking, of course there is a way to make this code less redundant. Let's not worry about this for the time being, but of course I copied like a huge chunk of code here. Not a good practice. So what's the difference here? It's the same difference we had in Think and Compute. One player is making the choice deliberately by entering coordinates. The computer player is making these choices automatically by calling on the method nextInt from random. And that's it. As long as this is a valid selection, we should be fine. So let's go back to main, and I'm actually going to do the same here. I'm going to print coordinate 2, 0 and coordinate 2, 1. And I'm doing this because I want to see the other player's selection, just to double check that it's working fine. And what I'm going to do, I'm going just to take out this break statement so that the loop goes forever. Okay, so those are the two boards now. Let me try to select row 2, 2. Good. So the other player selected 3, 11. Okay. And now I can select 6, 7. The AI player selected 3, 12, and so on and so forth. So each one of these players is selecting a certain coordinate. So that's nice. The next step we want to do, we want to communicate the result from one player to the other. We want to tell player 2 that player 1 is trying to target you at these coordinates. Is it a hit or a miss? And same thing for player 2.